We're going to cruise pretty fast in this video. I'm assuming you've already learned something about hyperbolas in the past in a conics class, but if not, here's the basic steps I'm going to follow. We're going to first figure out if this is a horizontal or vertical parabola, hyperbola. That's step number one. And to do that, I want to focus your attention on this negative sign. The negative y squared matches this equation right here for a horizontal vertical hyperbola. We're only dealing with the horizontal one. That makes life a little easier. That we know which shape it is. How about the standard equation? Can we rewrite this right here in standard form? Well, here's how you go about it. X squared doesn't need any playing around with. It's already a perfect square. But the y squared is not a perfect square. And to make it a perfect square, I'm going to put it in parentheses. Notice that means I have to change the sign of the 4y also. And I'm almost at a perfect square. I just need to make one more modification. I need to add something. Normally your perfect squares have a y squared term, a y, and then a number. The number in this case is going to be 4, right there. And you'll see where this goes in a moment. Just balance the equation first. Okay, I've got a minus 4 on the right side to match the minus 4 on the left side. Watch that parentheses. Now, as I move this into perfect square form, look what happens. And this is the reason for all of this. See that? Oops. And I notice now that I should have had a 5 here. Maybe someone caught me before in the video. Good for you if you did. So now I've got this form. I can say divide by 1 everywhere. And obviously I don't need to say 1 divided by 1 on the right, but now look, I've got a standard form equation, which answers question number 2, standard form, and it helps me know where the center is located. The center for this hyperbola that I just drew is at h comma k, which according to my standard form is going to be 0 because x was not shifted, and 2 because k was shifted. So where's that going to be? Well, let's draw a nice thick dot for 0, 2. That's going to be right here on the graph. And what are A and B? Those define a box that goes around the center, A to the left, A to the right, and B up and B down. Because they're both equal to 1, it's a box that's exactly 1 left, 1 right, 1 up, 1 down. Now what's the purpose of that box? That box is one of the most important things for a hyperbola. It helps you draw your asymptotes. So asymptotes go through the center and the corners of that box. In other words, they have a slope which goes up. I missed that one. Get back on there. They have a slope that goes up B and over A. So there's my asymptotes. And the hyperbola is going to be this goofy looking shape that sort of comes in here, touches that box, and then shoots off to the other side. And same on the left. Comes in here, touches that box, and shoots off. So there's my hyperbola for this equation that I was given in this problem. Now, remember what the question was. What's an asymptote? Which one of these equations listed is the asymptote? Well, they all have plus and minus slopes, so that makes sense. But where's the y-intercept? In other words, where's the center of this hyperbola? That's the y-intercept of these asymptotes. Now, what I just said won't be true if you have a vertical hyperbola. That would be a little different. You have to be careful in that case. But in this case, because those asymptotes pass through the y-intercept, I'm simply looking for the y-intercept that has plus 2 on it. Okay, that's going to match the y-intercept right here for those asymptotes, and that's the equation. You see, the equation that's drawn here is negative x plus 2. That's this line going from up and left to down and right. It could have also been positive x plus 2, but for whatever reason, I was given negative x plus 2.